Okay, today I'm going to do some Python scripting and go through some of the changes I made to the rig since last time, the rig controls. So previously this rig was connecting the attribute, the rotation attribute to this whatever joint it would control, and then it would just simply parent constrain itself, disregarding the rotation on the control itself. So in this case, what I actually want to do is I want to change the setup, and then I obviously created a Python script to do that. For this, I want to actually change the setup so that I want to group in between this control and the joint that it's going to bind to. That's going to allow the pivot point to be set for the group at a different location, and then the control will also follow along in orientation and stay oriented along with the joint, which I'll show in a second. Now let's just quickly go over the change, and then I'm looking to create a new script to go through all the controls and bind them all automatically, and then I also want a script to do the exact opposite, to go through all the controls and unbind them automatically, so I can make any adjustments or whatever as I need to. It's always important to have something that you can undo quite easily. So let's take a look. The changes in the script is simply to create a group, reset the transform, and that will actually center the pivot on the group, and the group will only contain the control, and it will also obviously keep its orientation that it had because of the parent group. And then the parent constraint is going to go from the joint to the group, so the group is going to be parent constrained to the joint, and then the attribute, the rotation, is going to be connected on the control. Okay, let's take a look and see what happens. So I'm gonna just test this script on this joint here and just see the difference to what we had previously. I'm just running that script now. So now you can see under the control group there's a new group for each control, containing using the same naming convention as the control, just with underscore group behind it or after it. And then inside the group is the control itself, and the you can see the parent constraint is now on the group, and the control itself has no constraint. So the group itself shouldn't be moved or rotated. Normally, just when you click, you want to make sure that you're selecting the control. And now these controls follow along with the orientation of the joints, which is working differently to previously how it was. Previously they would still keep their orientation. Now this also allows you to locally rotate more easily using the local rotation of the joint. Now I want to take this one step further and actually want to create a script that's going to do all of this for all the controls it can find, so I don't have to click these things automatically. And because I'm using a naming, I also did the exact opposite here, to undo just this one particular one. As long as you select the control first in the joint, it will go and disconnect the attribute, the rotation attribute, from the control to the joint, get a hold of the group's parent constraint and simply remove it and ungroup the group, meaning the group will disappear. So if I run this script, you can see the group disappeared from this control. It's no longer bound or connected, and this joint is free to be manipulated or moved or whatever you want to do. So let's just undo these guys. Now just also keep in mind this will only work if the controls themselves are oriented exactly the same as the joint. So the orientation of my joints are very important. If I just quickly take a walk through these guys, let's see. You can see they're all oriented the same. There's no rotation on any of the joints, and if I take a look at my controls, they also follow the same orientation, which is exactly what I want, and there's no rotation set on the controls initially. So now I'm going to jump into some Python scripting using the script editor. So the first thing I probably want to do is get a hold of all the controls. I don't want to get a hold of all the joints, because not all the joints have controls, and I don't want all the joints to have controls, especially not for more complex rigs. So I'm just going to use the list command to do that. Get a handle of the controls. And I'm just going to say give me everything that ends in the word control. Now if I had IK controls and things like that in here, this wouldn't work, so I'd have to probably come up with a better naming convention like FK control or something like that. But for these guys I'm not going to be creating IK, and then I just want to quickly loop through this and just display it. And I should just display all the controls. Now basically for each control I want to run this function here. So I'm going to create a new function. I'll call it connect control. It will take in the joint and probably I'd say rather the control first and then the joint. So the driven would be the joint, because that's going to be driven by the driver, and the driver is the control. I don't really need this print. The group name is created by the driver's name and just appending underscore TRP. Then it's going to create a group, reset the transform and center and pivot. And here's a very important point that I also need to make. Let's just close this for a second. Looking at let's take this guy. This would be for the upper jaw. So his pivot point currently is set there. If I run this script correctly, select the group, and now you can see the pivot point is actually of this group. It's actually by the same point as the joint that it's bound to for the group. That's what I want. So that then when this joint here rotates, this guy is going to be, because he's a child of this group, he's going to follow along nicely and get his orientation set correctly, because the pivot of the group is also quite important. If that's not set correctly, then you're going to get some weird things happen when you start moving the controls. That's why this match transform is in here. Then it's simply creating a parent constraint, connecting the attribute. I think this function should be fine. I'll do the disconnect in the disconnect. So let's just do one test. I think it's break to break out. Just want to make sure this project is saved. Just want to double check the documentation quickly. Yeah, okay, so let's break. Should be fine. So this rigging process is always evolving. You're always finding new ways and different ways of doing stuff. For the next game, I'd probably do something similar to this, or it might change. This kind of stuff it's always evolving. Okay, so I just want to hook up one and see what happens. So I'm just going to call connect control, but I do need to find the corresponding joint for this control. Now, because I'm using a naming convention where the name matches the joint, but it's just underscore control, finding the joint's actually very simple. It's just a simple string replace. As long as my string or control name doesn't contain the underscore CTL in it anywhere else, because it will replace that too. This should work fine. And then I can just call this function with the control in the joint. Let's see if this works. I only want to do one and then it should break out. So the first one it's going to do is probably going to be if I just run it up until there. Arm lower control, the left arm lower control is this guy here. Let's see what happens. Okay, it finished. Yeah, worked. So to undo it, you could always just use Maya's undo. There we go. And I'm going to run it through for all of them. Okay. Replace this function here on my shelf, so I'm no longer going to be running these individually. I'm now going to be running them in totality. So all of these should now be connected. Let's get rid of the geo for just a second. Grab a hold of these. So my head's rotating there, I wonder why. Spine 1 control is wrong, I think. That should be spine 2 control. So, let's undo. There we go. This control has the wrong name. Which means this one will have the wrong name too. This should actually be 3. Also a good way to find any bugs you have in your rig. And tail 1 goes to tail 1. Let's try this again. Now I can just hit the script here. And it finished. Hide geo. Alright, that's what I expected. Cool. Now you can see they're keeping their orientation. relative to the joint they're bound to. Alrighty. Now I just need to create the disconnect script, and that will decouple all these controls again. And once again, I'll just quickly pull it into Unreal Engine just to make sure everything's still working. Just want to check the fins. Yeah. It's also pretty simple to create a script to just zero out all the rotations on all of your controls with one click. We'll even bind it to a hotkey. But you don't usually use that too often, just when you're starting to set up the rig like this. Okay, let's create the disconnect script. So for the disconnect script, I'm just going to be doing the exact opposite what I was doing for the connect. Because I have the connect function here already done, I can just go ahead and just change this. So things are going to start changing from here. And I'll just call the disconnect script there. I'm still going to be going through the controls. I'm not going to be selecting the group, it'll automatically build up the group name here. Alright, let's see what happens when I run this. All these groups should disappear, or everything's going to explode. There we go. Copy that. Place it. And I also wanna, so these guys are broken again, they're not connected to the spine in any way. And the spine's free to rotate again. I wanna back up this shelf quickly. I'll just pop that over my backup folder. Okay, so I'm going to run the connect up again. Now they're connected. I'll do a quick bind skin and just test it in Unreal Engine. So just select the geo and the skin, do a smooth bind, just use the default. So still need to paint weights on these. And that's what I wanted. Check the fins quickly. So what makes this nice is as the head rotates, these are no longer facing a funny orientation, so they should be oriented along with the joint that it's bound to, making this motion or animation that you would want to do here much easier. Obviously I haven't smooth painted the weights or anything, so let's just test this quickly in Unreal Engine. I'm just going to select the mesh, the spine, export as FBX. and I'm not choosing animation or beg, and it will export skins and blend shapes as well. I have no blend shapes. It's going to complain about the constraints, which is fine. Shouldn't be exported. Oh no, they can't be. Just bring it in quickly. I'm skipping materials and textures because I don't really care about that now. And I'm more interested in the skeleton. So yeah, no errors. Imported it fine. So I think this is the rig I'm going to end up using. Cool, that was a nice short one. Thanks for watching.